Of course, if it's true for 2, it's true for 100 billion also, right? Induction. So this implies that log of determinant of identity plus x is a concave function, okay? Because it's negative, right? Sum of concave functions. Concave function. So let me just write this. So instead of question mark, we have concave. Okay, concave looks like this, convex looks like the downward. This is a nice thing to look at, right? So let's go back and see what is it that we did. So essentially we looked at one way was we took identity plus as common, and then t times y times identity plus x whole inverse is what we got, and then we assume that this is decomposable, and therefore we proceeded and we got this, right? That's what you get. Is that fine? Okay. Okay, another question. So anyway, you have to think about this. If it's a question in linear algebra, okay. Okay, I'll say belong to implies AB belongs to this. Not really, or no, or yes. Okay, let's not. Okay, symmetry is too much to ask for. Let's say it's positive semi-definite. Implies AB is positive semi-definite? Question. If so, you should prove. If not, you should give a counter example. Okay. Yeah. Okay. Anyway, so let's revisit this. Okay. So keep these questions in mind. In the next class, we will discuss and see if it's true. Okay. Yeah. So at least we saw a few examples. Let's look at one more example of a convex or a concave function. So the function looks like this. Okay. Okay, maybe you can add one more number C. Okay. So this is what kind of a function is this? Okay, x transpose ax, what kind of a function is that? Okay, so let's give me some, I'll just tell you one small thing. X squared plus bxy plus cy squared, right? What kind of a function is this? It's quadratic, right? In xy, right? I can write this in a different way, right? So xy something times xy. Do you agree? Now I can fill something here, some numbers, so that when I take the product, I'll get this. Now my question is, again, it's a homework problem. You should figure out what numbers I have to fill so that I get this. How do you do that? Well, you call this as some C1, C2, C3, C4 or something like that, and then multiply this explicitly. You'll get an expression, coefficient by coefficient, you map. Right? That will give me what C1, C2, C3, C4 are. Right? It's the easy thing. Okay. So I can think of this as a vector V transpose. This as vector V. So it's V transpose some matrix times V. Right? It's called quadratic. So this is also a quadratic function. Right? In general, if I write x transpose px or x transpose ax, it's quadratic. Now we have a quadratic function. So is this convex? Obviously not, right? Quadratic is, in general, it could be like this also, right? Can it be like this? Huh? Any idea? How do you show that this is convex? What is it that you have to do? You have to take the second derivative. In this case, Hessian, right? What is Hessian? First derivative is what? X transpose px. Well, matrix derivative you may not know, or vector derivative. So let's use intuition, or you can just download the matrix cookbook or whatever, the derivative cookbook, couple of pages of these kind of results which you can use. So what is the derivative of, let's say, px squared? In one dimension it will be px squared, right? What is the second derivative of px squared? Come on, what is ax squared derivative, second derivative? 2a, right?